You could see that coming. Let me explain with a graph. On one axis, we have project complexity, basically how big is our project. And on the other, we have pain. Pain is an indicator of code quality, and it is also measured in WTS per minute. The correlation between the two, it's not linear. The more code you add, the more dependencies you have between the code, which increases pain exponentially. There is a section on the left that everyone is happy. The code base is small. You can easily understand what's going on. You can easily refactor things around if you need it. You can take some terrible decisions, and it will not really matter in this case. Unfortunately, we evaluate front-end frameworks and proof of concepts with projects in this category, which doesn't expose real-life problems. It's usually a to-do application. It doesn't really solve the problems. On the other side, we have really large code bases. And the only known solution to this category are microfrontends. Let's see some hands who is familiar and working with microfrontends. Okay, many people. And who is happy with microfrontends? 3 people. I will love your insights. You should make a talk next year. You should talk to Aris. Because my experience more or less aligned with the rest of the room. When you have a really big code base, you have a lot of issues. And then you introduce microfrontends, and then you need to solve again routing, state management, performance, code duplication because microfrontends on top of your existing issues. I'm not against them. They're adding more problems than they solve if you add them prematurely. That's my point. I will not talk about microfrontends today. There is a talk at 5 if you are interested about them. And I will not talk about tiny code bases as well. I'm going to talk about what's in between. And probably most of us are working on this kind of projects every day. First, let's see what the big front-end frameworks think about this matter. React doesn't have an opinion. This is taken straight out of their docs. Basically, it says, I will do things reactive. You figure out architecture, state management, routing, and everything else, which is fine. There are more opinionated frameworks like Gatsby, Remix, Next, if you want, but React doesn't take decisions for you. The same applies for Vue, but Vue doesn't acknowledge this at all in their official docs. The only speaker that had a keynote about this during the last Vue.js Amsterdam meetup conference, proposed a flat folder structure and having the component name as a prefix to group related components together. Of course, you use the tool application to demonstrate this, and you can tell that this will not work. I think even for small projects, this is a terrible idea. Even for medium, even worse. Lastly, we have Angular. Angular is more opinionated. It has modules and feature modules by default, which is one of the many things that you need to learn when starting with it. It keeps a lot of people away. But Angular is actually right. Having small independent entities inside your code base is the key to a reasonable architecture. So let me show you what works for me. Everything starts with a router. It's a core functionality in any application. It helps us map the current URL, which is the entry point, to a page component. For me, it's important to have them all in one place. You can have each module declaring its own routes. But then if you have different user roles with different access rights or dynamically declared routes, it's very hard to understand what's going on in the code base. Having them only in one place makes sense. And when this gets out of hand, it's a good indicator that we need to move microfrontends. Then we have pages, again, all in one place. It's important, though, to be very, very lightweight. Just declare a layout, some components, and that's it, nothing more. If you find yourself declaring too many components, just group them in the new one and use that instead. Then we have layouts and components. Layouts are very important to have a consistent look and feel across the whole application and reduce a lot of boilerplate code. We have components, which is all global components, and you know that global is a bad thing in programming. So actually, this should be, you should avoid adding things here. It's not realistic having nothing here, but if you try, please do, because your application needs to be split in features, and most of your code should be inside this folder. Features folder. We expect many subfolders inside here. I will return in the next slide. Let me show you first some more folders that you might are already familiar with. We have assets for our static assets, images, fonts, and styles. We have the lib for third-party configurations like Bootstrap, Tailwind, Axios, or whatever is trending this week. Then we have types. Sometimes you have some globals in your code that you need to declare them somewhere for the TypeScript compiler to stop complaining. And lastly, we have tests. Not for the spec file. I believe the spec file should be right next to the component tests. But often you need some mocks, some helpers, and some configurations, and this is the place for them. So let me backtrack a bit. We have the features. Again, we expect multiple subfolders inside here. An example can be the profile feature. And we have, sorry, spoilers. And we have even for some folders inside it. We have API for all our fetching logic. We have the state management inside the stores folder. We have components for this specific feature, composable types as well. And we also have an index file that acts as a public interface. Everyone should, you can see what's going on just by seeing this file, and everyone should only import from this. Let me convert this to a more familiar view. I think this is simpler to understand. Again, let me repeat, we have router that maps the URL to the pages, layouts, components, features, asset, lib, test, and types. Inside features, we expect multiple subfolders, one for each feature of the app, and each feature has API, stores, components, composables, types, and an index file. If you want to take one thing away from my talk, this is a slide. I'm calling them features because modules are something different in Angular and Next, and was causing some confusion. And one more thing to note is that each folder inside the feature is optional. You might not have fetching logic, you might not have actually having stores and composables makes no sense because they were probably doing the same thing. The only mandatory thing is the index, which let me expand a bit on this. It's a popular pattern in the React world that I think it makes a lot of sense. It helps you detect circular dependencies when your module imports something from another module, and that module also imports something from yours. You get a generic error. This doesn't solve that, but helps you detect what's going on easier. And I think the imports also look a bit cleaner this way. You can enforce it with a ESLint rule. And about pages, I told you that they need to be lightweight. This is what I'm talking about. I'm using Vue, but I hope the code is easy to understand. In Vue components, we have three sections: a script, a template, and the styles, which in this case are omitted. Everything imported inside the script will be automatically available in the template. And this template just has a layout, some components for the main content, some components from the sidebar, and that's it, nothing more. So this is the architecture that I think it works more or less. There is an optional step if you want to build a quality code base, and this is adding a design system. A design system is a collection of components, guidelines, and design patterns created from the designers and implemented by the developers. They need to work together in order to build this, which is the main benefit. I have worked in many companies that there are different departments, each one doing his own thing. And you can tell from the website that different teams designed this section. A design system solves this. The goal is that the end user that gets a feature, the feature will look more or less the same no matter which team designed or implemented it. There are many ways to implement it. There are some ready-made solutions like bit.dev or Zero Height, or you can have a custom implementation like, again, many ways to do it. I'm going to show you a simple way. It's by adding a new folder. I'm calling it for UI. And then inside we have even more folders. We have all our design tokens inside the token folder implemented in CSS or SAS variables. We have helpers for all our mixins and code to do theming, etc. We have styles for all global styles. An example will be reset.css. Then we have components. This is where our component library will go. And we have three options here. We can have a third-party library like Bootstrap, Beautify, or Element UI, or whatever, which sounds easy and works until it doesn't, in my experience. I can spend a lot of time removing third-party UI libraries for code bases and most often for memory leaks. Another solution is to have a custom implementation, which sounds hard, but it's actually even harder if you want it to do it properly. That is, you need to do accessibility, interaction between components, different screen sizes, etc. And there is also a third option, which is a hybrid approach based on headless component library. A headless component library is a library that with functionality but without styles. You need to write the styles according to your branding, and I think nowadays it makes the most sense. The most popular and my favorite is Radix UI if you want to check it out. And last thing, it's the docs. Again, a design system is more than a component library. You need guidelines to do your branding, interactions, accessibility, and everything else. And then you use a tool like Gitbook or Storybook in order to have this available for everyone. I think that was it. That was a theory list. Sometimes in practice, theory doesn't work. That's why I had a code base, but my laptop didn't behave today, so I will not. But I will plug this the code base if you want to see it. This is my handle. I'm using it almost everywhere. I've seen that many people posted the main speaker showing their cuts, but I didn't, and I will post it on Twitter afterwards. So if you have any questions or feedback, let me know.